Hi again. Welcome to the second of 3 videos on financial loans, analysed with geometric series. In the previous episode of this story, we used series to determine how much our regular repayments should be and also estimated our maximum realistic loan, given our financial restrictions. In this video, we will use the same approach but examine how long it will take to pay off a loan, how to deal with missing payments, and how to deal with missing interest. So the first question we're going to address is, how long will the loan take to pay off? Well, for an example, my friend India wants to borrow $12,000 with interest at 6% per annum compounding monthly. She wants to pay off the loan with monthly repayments of $180 each because that's what she can afford. So how many years and months will it take India to repay the loan? Well, at the end of month 1, she borrowed the $12,000. She has interest owing on that, so multiply by 1.005, and she makes her repayment of $180. Same thing as usual. End of the second month, she's got all the end of month 1 outstanding, so 12,000 minus 1 times 1.005 minus 180, and she pays interest on that, so times 1.005, and then another repayment. Now we'll remove the brackets from that to make it a little bit easier to look at. So we've got 12,000 times 1.005 squared, and then the minus 180 times the 1.005, and then our final minus 180. Now we do the same at the end of month 3. We take everything India owed before and multiply it by the interest, 1.005, and another $180 off, and so we can now remove those brackets and do a little bit of factorising as well to give us the last term, as you can see. So I'll leave that last line down there so that you can see how we're going for summarising the end of month 3 payments. So the end of month 3, we've got 12,000 times 1.005 cubed minus 180, which is the value outside of the brackets, and then we can simply do our sum of 3 terms using our normal approach of 1 minus 1.005 cubed over 1 minus 1.005. Now, at the end of month n, we can generalise this to replace the 3 in the previous expression with the n in our new expression. At the end of the period of her loan, the balance is going to be 0, so this expression that we've just got is going to be 0, and we just have to now solve for n. So step 1, remove the denominator by dividing into the term before the fraction. So it's minus 180 divided by 1 minus 1.005, which in your calculator gives plus 36,000. So we rewrite the expression with the plus 36,000 into it, equals 0. Expand the brackets and collect the like terms. We've got a 1.005 to the n in 2 of those terms. So we're going to bring those together out with brackets in front. And then we're going to form a logarithm and use the calculator. So 1.005 to the n is equal to 36,000 divided by 24,000. Then taking the logs and also using our change of base formula straight away, we have n is equal to log 36 over 24, don't worry about the thousands, over log 1.005, which converts to 81.30 months, which is 6 years and 10 months by the time India's repayments have been finished. Second example, how much do I save with an interest-free loan? Now, we often see the retailers showing us interest-free loans about this, that, the other. Let's have a look at them. Example, Cicely wants to buy some computer equipment now she has started at uni. It will cost $3,000. The shop offers Cicely 4 months interest-free terms at 12% per annum monthly reducible over 2 years. How much does Cicely save compared to not having the interest-free period? Well, using all of our previous strategies, which you must know by now, we can simply write down or develop m is equal to 3,000 her loan times 1.01 to the 24, because without the interest-free period there's 24 months, minus the repayment, and then the sum of the 24 terms, 1 minus 1.01 to the 24, over 1 minus 1.01. Put in your calculator. Cicely has to repay $141.22 per month if she doesn't have the repayment period. Now we can have a look at the context in which she has been given the 4 months of free interest free. At the end of the first month, she's borrowed the $3,000, no interest added, just a first repayment, so minus R. Second month, no interest added, so she subtracts another R from her amount of loan, so that's minus 2R. Same with month 3, and so end of month 4, which is the end of the loan interest-free period, is $3,000 minus 4 repayments. Then the interest starts. So at the end of month 5, she's got everything she had at the end of month 4, 3,000 minus 4R, times the interest, 1.01, minus the repayment. At the end of month 6, all the same thing, what she had outstanding, all times 1.01 minus R. Now I'm going to expand those brackets. Pretty helpful in this sort of context. So you expand them all, 3,000 times 1.01 squared minus 4R times 1.01 squared minus R times 1.01 minus R. So at the end of month 7, same deal, all what we had outstanding times the 1.01 minus the R again. So I'll leave the bottom line down there again, and we'll do our summary and bring things together. So at the end of month 7, she's got 3,000 times 1.01 cubed, minus the 4 repayments that she made during the first period, times 1.01 cubed, and then minus R outside of 1 plus 1.01 plus 1.01 squared. Now let's have a look at the numbers here. We've got a month 7, which is the current month, 3 and 3 for the indices applied to the loan and to the repayments, and we've also got 3 terms. So clearly we have a very good pattern here. The 3s are 4 less than the 7, which means that 4 months interest free. So at the end of the 24 months when the loan is fully repaid, we can simply write, because it's going to be equal to 0, 3,000 times 1.01 to the 20 on one side, because the 24 months minus 4 is 20, and on the other side we're going to factorise out the R, and it's going to be R outside of 4 times 1.01 to the 20 plus sum of 20 terms, 1 minus 1.01 to the 20, etc. Put it all in your calculator. R turns out to be $136.08 per month that Cicely has to repay. So she's going to save 24 months lots of the difference between the original price that she might have paid, $141.22, minus the interest-free amount per month, $136.08. So she's saving $123.36, which is not bad because that's nearly a full month's repayment. So well done. Now we come to an example where we have missing repayments. So what happens then? Give you an example. Shane borrows $5,000 to fund a trip overseas at 9% monthly reducible over 4 years, with the bank setting his repayment at $125 a month. His big departure day arrives 6 months after he commenced his repayments. He leaves, but Shane forgets about his repayments. Not good, my friend. Shane misses 3 repayments while he's away. On his return, the bank manager said, "Okay, Shane, no penalty, but you will have to repay a bit extra to compensate and still complete the loan in 48 months. How much does Shane's monthly repayment increase?" Well, before his departure, Shane paid 6 payments of $125. So the balance owing at the end of 6 months is just calculated in the normal way. Put it in your calculator, and it's $4,465 because we're just using the 6 months. Now, at the end of Shane's first month in Wonderland, he is charged interest, and that continues in the second and third months of his holiday. He doesn't know it, he doesn't realise it because he's out enjoying himself. So at the end of month 7, when he's away, That's $4,465, the amount outstanding, times one of the interests. On the end of month 8, we've got 2 lots of interest being charged, and at the end of month 9, we've got all 3 lots of interest. So his balance now has increased to $4,576.44. So on his return, he needs to repay that $4,500 over 39 months, because that's the balance of his 4-year loan. Using the patterns established earlier, Shane's repayment is described as 0, because that's the balance he's going to have at the end of 4 years, is equal to the new balance, 4576.44, times the interest at 9%, which is 1.0075 for a month for the 39 months, minus the R, the repayment, times the sum of 39 of interest there. So put that in your calculator. R turns out to be $135.78 per month. So it's gone up a little bit, but not too bad for Shane. Now, to bring all these different kinds of questions together, we can notice first the steps are all similar from one type of problem to another. We're doing the same kind of things, so you've got to be able to get used to that. Secondly, you need to talk to yourself through what is happening. Describe it as you're writing it down to keep your concentration going, and you need to establish a clear pattern. So you write down as much as you need to. Write the summary equations carefully and take your time. Don't rush it. It's going to be there for a while and you've got time on your hands. They'll give you enough time in the exam for that. And fourthly, although you can generalise from what you develop, you can't just copy or remember something from a previous question. Believe me, there are too many little twists in these questions to be able to do that, so take your time. So there you have 3 more loan situations. I hope you now see the similarities from one situation to another, but also the differences required in technique from one problem to another. In the next video, we discuss other variations when changing the normal loan conditions, such as interest rate changes and making a substantial payment. In the meantime, consolidate what you've learnt here by doing the Loans Test Yourself questions on the website drjays.com and come back and see me. Hit the like button and subscribe if you haven't already, then you get notification about new videos. Good luck. See you in the 3rd loans video shortly.